Hello, programmers! Welcome to the discussion on data types, variables, constants, and literals. In addition to these topics, we will also be discussing magic numbers. The following data types are referred to as primitive because they're the most basic and lowest level of data types. They can be grouped into three basic categories: numeric data types, integers and real numbers; text data types, in C++, Java, and Visual Basic. String is actually an object instead of a primitive data type, but it is covered in this discussion anyway. The Boolean data type can only hold a true or false. The null data type is used to identify when the data type is not known. Data types can also be part of the definition for literals, variables, and constants. A literal is a value that is part of the compiled program. It does not have a name and cannot change during the execution of a program. A variable represents a storage location in RAM that has a data type and a name and can have a value placed in it during the execution of the program. Named constants are similar to both literals and variables in that they cannot be changed, but constants can have a data type. A literal is a value that is part of the compiled program. It does not have a name like variables or constants, and literals cannot change during the execution of the program. Here are some examples of literals. 47 is an integer literal with no decimal point or digits past the decimal. 3.14185. Real number because it has digits past the decimal. True. Boolean literals can either be true or false. Double quote. Greetings. Double quote. String literal. It is enclosed entirely within double quotes. A variable represents a storage location in RAM that has a data type and can have a value placed in it during the execution of the program. Variables have declared with a data type and a name. Memory is allocated to hold the data. Variables can hold data, and the data within a variable can be changed by the program. Here I see a variable that resides in memory. Its name is score, and the contents of the variable are set to 47. A value must be placed in the variable before it can be used as part of a computation. A value can be placed into a variable when it is first declared, initialized, or the value can be placed in the variable later in the program. A variable is declared the same way in Java, C, or C++. It starts with a data type followed by the name the programmer wants to give the variable. A variable can be initialized to a value at the same time the variable is declared, or the variable can just be declared and initialized later in the program. It is also possible for the programmer to define new data types, which are usually made from a collection of existing data types. The enumerated data type was not listed yet. An enumeration has a name and a set of members. Each member represents a constant. Enum is short for enumerated data type. Enums are an easy way to define a list of constants. For example, an enum could be used to define a numeric value for each month instead of defining them individually. Jan equals 1, Feb equals 2, March equals 3. Here is a sample program in Java that uses the enumerated data type. I am creating a new enumerated data type and calling it traffic enum. It only has three possible values: red, yellow, and green. I can use these values later in my program. In Java, the enum declaration must be in either its own file or placed outside of the definition for main. Here I see that a variable named South Street is being declared using the data type traffic enum. It can be initialized to any of its three possible values: red, yellow, or green. In this program, it is being set to green. The first print line statement will output the light is green. The second print line statement will output the numeric value is 2 because in Java the enum definition starts at 0. Red would be 0, yellow would be 1, and green becomes a 2. Using the enum is fairly similar when using C or C++. The enum statement defines the 3 possible conditions, but the enum by itself does not create the new data type. The typedef statement is used along with the enum definition to actually create the data type. It is possible to create the data type in C or C++ at the same time by defining the enum. Typedef, enum, traffic enum, open curly brace, red, comma, yellow, comma, green, close curly brace, traffic or light, semicolon. Since South Street is defined by the enum, the if statement can compare South Street to one of its predefined values. We can also find the numeric value of the individual definitions within the enum. One thing that C and C++ can do when defining the enum is to initialize the values within the enum. For example, enum, months enum, open curly brace, Jan equal 1, comma, Feb, March, April, May, etc. In this case, Mar for March would be a 3, but if Jan was not set to a 1, then starting from 0, March would be a 2. I am providing a sample C program. It is identical to the C++ program, except that the printf statement is used instead of cout. Even Visual Basic has the ability to define constants using the enum. Since VB does not use the open and curly braces for begin and end, we need to use the word end, enum, to identify the end of the definition for the enum. Similar to Java, when setting South Street to red, we also need to identify where red came from, such as South Street equal traffic enum dot red. Back to the numeric data types. Integers can only hold whole numbers, both positive and negative. The words real and floating point can be used interchangeably. Some programming languages call floating point numbers real, while others use some form of floating point. Here is a big question. When creating numeric variables, should an integer or a float be used? A number like 3.14185 has digits past the decimal point and cannot be stored into an integer. Only whole numbers can be stored in integers. Integers can be converted from decimal used by humans to binary used by computers with no loss in precision. Although float is now very accurate, occasionally small errors creep in at many digits past the decimal point. Whenever possible, use integers instead of float. Integers are whole numbers. The values of integers can be positive, negative, or 0. Here are some examples of integers. 79 is a positive integer. Negative 85 is a negative integer. 0 is an integer 0. For signed numbers, the most significant bit is used as a sign bit to indicate a positive or negative number, leaving one less bit for the value. A 0 in the sign bit position indicates the number is positive or possibly a 0, and a 1 in the sign bit position indicates a negative number. In this example, the number 73 is stored in a byte, which is only 8 bits. There is a 1 in bit values for 64, 8, and 1. Converting the binary value of 01001001 to decimal gives 73. 8 bits, including the sign bit, can be used to store a value from negative 128 to positive 127. More bits are needed to store a number greater than 127. The short data type uses 16 bits and can store a number from negative 32,768 to positive 32,767. The int data type can store a number in excess of plus or minus 2 billion. The long data type can store a humongously large number in excess of plus or minus 9 quintillion. A quintillion is a 1 followed by 18 zeros. Have you heard of the counting down song, 100 bottles of beer on the wall? A quintillion bottles of beer on the wall, a quintillion bottles of beer. Take one down, pass it around. 999 quadrillion, 999 trillion, 999 billion, 999,999,999 bottles of beer on the wall. 999 quadrillion, 999 trillion, 999 oh, forget it. I give up. Floating point numbers can contain digits past the decimal point. Floating point numbers are called real numbers in the math department and some computer languages. Examples: 7.0, 3.1418579, negative 85.3357, 0.0, 0.00000000578 is a positive value less than 1. Negative 0.00000000578 is a negative value less than 1. You may have been exposed to scientific notation in a science class. Scientific notation displays numbers with only one significant digit before the decimal point, and all the rest of the digits are shown past the decimal point. This is called the base. The number is then multiplied by some power of 10, which establishes the actual size of the number. Computer programs and even many calculators display the power of 10 using the letter E followed by a number. For example, E3 means 10 raised to the third power. Floating point numbers use data types float or double. Floating point numbers can be displayed using the fixed point notation, which looks like a normal number, or in scientific notation using base and exponent. Here are 3 examples. 5,167 is the same as 5.167895 times 10 to the third, and displayed as 5.167895 E3. 0.000542 is the same as 5.42 times 10 to the negative 4, and displayed as 5.42 E negative 4. Negative 0.00004 is the same as negative 4e negative 6 and displayed as negative 4e negative 6. Here are a couple of hints. A number between negative 1 and positive 1 has a negative exponent. A negative number has a negative base. The original IBM PC used the Intel 8088, a 16-bit processor with an 8-bit data bus. Unless you installed a separate 8087 math coprocessor, floating point calculations were done in software. In either case, the computer was very slow and not very accurate when processing floating point numbers. The data type float used 32 bits and was used to declare floating point variables. As processors became faster and cheaper, the math coprocessor was included with the main processor. We now use double precision floating point numbers with the data type double, which uses 64 bits. Double means double precision floating point data type. You will probably never need to get down to the bit level for floating point numbers, but it is good background information to know a little bit of how they are stored in memory. In a manner similar to how numbers are held in scientific notation, the float and double data types store numbers with their exponent and fractional part, but in binary instead of decimal. The float data type stores a floating point number using 32 bits, and the double data type uses 64 bits to store a floating point number. When looking at the differences between the range and precision for the two different formats, it is easy to see why the double data type is used most often with modern computers. The decimal data type is available on Microsoft Visual Basic and C#. but not in C++. Decimal also stores floating point numbers, but internally the number is stored as a collection of individual decimal digits and a decimal point location instead of converting the number to binary, similar to scientific notation. The decimal data type is good for financial applications. Floating point numbers could have some rounding errors when being displayed. Here is an example of computing interest on two separate accounts for a customer of a bank. The interest on the two accounts might be computed as 3.596 and 5.598. When they're added together, the total is 9.194. But when the numbers are displayed rounded to the nearest penny, the second column would be displayed. It would appear that the bank can't do simple addition and the customer is being cheated out of a penny, even though the internal computations were correct. Suggestion: in Visual Basic or C#, use the decimal data type instead of float or double for currency calculations. Since an integer is a whole number, conversion to double is easy. Converting from a float data type, double, to integer poses some problems. What should happen with the digits past the decimal point? An integer can be easily converted to a double. Java, C, C++. Int value 1 equals 75. Double value 2 equals value 1. For either language, the result is 75.0. In Visual Basic, dim value 1 is integer equals 75. Dim value 2 is double equal value 1. C and C++ round down, also known as truncated. The result for value 2 is 75. The digits past the decimal point are lost. Value 2 is equal to 75 in C and C++. Many of the C and C++ compilers will report this as a warning, possible loss of precision. It is just as important to look at the warnings as the errors when your program is compiled. Java is strongly typed and will create an error if you try to convert from a double to an integer without specifically telling Java that this is what you want to do by using the typecast int in front of the double value. At the top of a Visual Basic program, you can enter the line option strict on to force the compiler to generate an error instead of doing an automatic conversion from double to integer. The best and safest way to convert from a double to an integer is to call a conversion routine in C or C++ to do a typecast. Then you have defined what you want to happen instead of just letting the compiler do what it thinks you may want. Visual Basic has two ways of converting a floating point value into an integer. There is toInt32 function method, and there is cint function method. Data types can be automatically promoted from a lower caste to an upper caste, but not automatically demoted to a lower caste. For example, an int can be promoted to a double, but not the other way around. The character data type is typically called char. It can hold a single character. The character can be alpha, such as capital A through Z, small a through Z, digits 0 through 9, special character, exclamation mark, sign, hash pound, $, percent, caret, ampersand, etc., or even a non-printable control character. In C and C++, the character data type can be treated like an integer when doing math operations on it. This is not true for Java and Visual Basic. For these languages, a character must be specifically converted into an integer. Math can then be performed, and then it can be transformed back into a character. It is important to remember that a string of characters that contain only digits is still a string of characters, not a number. There are conversion routines that can be used to convert a string of digits into a number. Here is how to create a character variable in Java, C, and C++. The char data type is used. The definition for a character literal uses single quotes. The double quotes are used for a string. Visual Basic uses a double quote followed by a small c to define a character literal. The double quote without the c is used to define a string. Characters are stored in memory using a binary code defined by the ASCII, Unicode, or ASCII character sets. ASCII stands for American Standard Code for Information Interchange. It is based on the 7-bit pattern punch tape of the old teletype machine. The teletype was used as a console on most computers until video display terminals were developed. This brings back memories of the good old days when we had to walk to the computer center in the snow, uphill both ways, to turn in our cards or paper tapes into the computer center, and then it would take maybe an hour, 2 hours, or even a day before we got our printouts back so we could look and find out what our bugs were. Maybe those weren't so good after all. Oh well. Back to the present. ASCII stands for Extended Binary Coded Decimal Interchange Code. It was based on IBM punched cards and is still used on many IBM mainframe computers. However, it is rarely used anywhere else. The ASCII chart lists each of the codes in hexadecimal and what the code represents. The first 32 codes are control codes. The important ones to know are BEL, BS, backspace, sorry, line feed, carriage return, and escape. It is important to note that the uppercase letters A through Z occur before the lowercase letters A through Z. Your program may need to convert the inputs from the user or disk to uppercase before comparing text when sorting data. For example, the hexadecimal code for the letter capital S is 53, or in binary 01010011, and the lowercase s is 73, or in binary 01110011. Since ASCII used only 7 bits, there were only 128 combinations of characters that could be encoded. This worked fine for the early computers built and used in America, but not sufficient to cover the many different characters used worldwide. The UTF-16 Unicode character set uses 16 bits and has the ability to have over 60,000 different characters. The first 128 characters in Unicode are taken from the ASCII character set. The following character sequences start with the backslash character and are used to represent control codes and other printable codes. Some of the important ones to remember are backslash single quote, backslash double quote, backslash backslash, backslash n for new line, backslash r for carriage return, backslash t for tab. For example, to create a string that has a double quote in it, use quote, he said to me, comma, backslash quote, what is your plan, question mark, backslash quote, quote. The backslash quote, quote at the end uses the backslash quote to place a quote in the string, and the final quote ends the quoted string. The C language uses an array of characters to store a string. This is known as a C string. A null byte, all zeros, is placed at the end of the string to indicate the end of string, EOS. Object-oriented languages such as C++, Visual Basic, C#, and Java store strings of characters in a string object. The string object is more robust and provides greater protection when processing strings. Different subroutines or methods are used to manipulate C strings and string objects. The array shows how the string hello is stored in memory. The index shows the position in the array. The values in the boxes represent the hex representation of each character. The square brackets are used to define an array. Without the square brackets, only a single character would be used and it could not hold a string. The null byte is automatically placed at the end of the string when the string is declared with quote marks. Here are examples of defining a string array in C and C++ or using an object in C++, Java, or Visual Basic. One difference to notice in defining a string object with C++ and Java is that the word string is capitalized in Java but not in C++. Java is very specific in stating that objects have their first letter capitalized. C++ is not quite so definite. Named constants are similar to both literals and variables in that they cannot be changed, but constants have a data type. Constants are usually declared in all caps to distinguish them from variables. Preprocessor directives start with a hash mark, also called pound. The pound-defined statement causes a text substitution in the rest of the source code. For example, when the word tax is found, the word tax is replaced with the characters 0.725 before the program is compiled. It is important that you do not place a semicolon at the end of the line, or the semicolon will also be substituted into your code when it is compiled. The pound-defined directive does not have a data type. Constants are declared in C++ and Visual Basic the same way variables are declared, except that the keyword const is placed at the beginning of the declaration. Although Java does not exactly have a definition for constants, the keyword static final can be used to make the equivalent of a constant. Maybe you want to compute tax on a sale at 7.5%, so you multiply the total by 0.075. The answer is correct, so you leave the program alone. Either you or someone else comes along later and can't figure out what the 0.075 is used for. The number just seems to have shown up in the program to solve a problem, but now no one else can figure out why it is there. The number is known as a magic value. There is another problem with using magic numbers. Suppose you use the value of 30 several times in your program. Later, you discover that the number should be 32, so you change all the copies of 30 to 32. Unfortunately, you also might change 300 to 320. Here is some sample code in Visual Basic that shows how to use a named constant instead of just placing a numeric value somewhere in the middle of the program. The concept is the same for Java, C, or C++. In the first example, the value of 0.725 is placed in the code. Someone later may wonder where it came from. But if a constant is defined at the top of the program, tax rate equals 0.0725, then the name constant can be used later in the program, and it becomes a little more evident why it is there. Another good reason to use the name constant is the value 0.725 may appear several other times in a larger program when computing tax. If the tax rate changes, all that needs to be done is change the value for the named constant, and this happens only in one place. There's a much smaller chance of making all the changes if it appears multiple times in the program. The Boolean data type can only hold a value of true or false. The Boolean data type is great for holding the result of a logical expression, for example, in C, C++, or Java. Light status equal switch 1 equal true or switch 2 equal true. In Visual Basic, light status equal switch 1 equal true or switch 2 equal true. The null data type is most often used when the program needs additional memory. When additional memory is allocated from the operating system, the OS returns a reference to the block of memory using the null data type. The OS has no idea of how the block of memory is going to be used by the program. It just provides the memory. Before the program can use the memory, it must use to typecast something like int, char, or another data type to identify how the block of memory will be used internally. Int buffer 1000 equals typecast int malloc 1000 times size of int. In C, allocate room for an array of 1000 integers. You have reached the end of the video.